1 minute, please. Yeah, sorry. Yeah. Uh, so we will come back. So I will share my screen. So for this session, we will continue with the network theorems itself. We need to complete 2 more theorems. So at least 2 more theorems. So here we go with the Norton's first. Am I audible to you completely? Another, it's fine, right?
Yes, sir.
Yeah. Okay. Uh, so if there is a doubt, please let me know through chat or you can unmute and ask. So Norton's theorem, we already discussed in Thevenin's theorems that the circuit can be make an equivalent circuit with the voltage source and in series with the resistance. So here in Norton's, we can state it like that. Norton's current source is in parallel with the Norton's impedance. There it is actually Thevenin voltage source in series with the load impedance. In series with the Thevenin resistance. So here it is Norton's current source is in parallel with the Norton's impedance. So through the figure itself, you can understand that if there is a circuit, we can represent that thing into a equivalent current source with a parallel resistance and then with a load resistance. This part is called Norton's equivalent circuit. Let me see with one example here. So please check it out. Take down this question. Determine the current flowing in 10 ohm resistor, 9 volt here, 1 ohm resistance is here, 3 ohm resistance is here, 2 ohm is here, and 10 ohm is here. Okay. So the question is determine the current flowing in 10 ohm resistor. So we need to find out the Norton current and also the Norton resistance. Norton resistance is completely same equivalent to the Thevenin resistance what we are followed at that time. So here in order to find out the equivalent resistance, we can have the resistance as we would first follow the IN. So in this figure actually the 10 ohm resistor is already allotted current flowing in 10 ohm resistor. So the 10 ohm resistor is removed and the terminal is being shorted. So that terminal is shorted and the terminal current is shown as shorted current is shown as IN. That is the Norton's current. Okay, clear? Norton's current. We need to find out the Norton's current first. So in order to find out the Norton current, in this equation actually we have 9 volt, 1 ohm, 2 ohm, 3 ohm resistance. So we can find out the equivalent resistance here. So 1 ohm, 2 ohm, 3 ohm in parallel. So you can have 1 plus 3 into 2 divided by 3 plus 2. That is 2.2 ohm equivalent resistance. 9 volt is the source. So the 9 by equivalent resistance will give you the source current from 9 volt. That source current is IT. It is represented. It is 4.09 ampere here. PS is 9 volt. 9 volt divided by the R equivalent 1 plus 2 and 3 in parallel. So R equivalent. So 1 plus 2 and 3 in parallel means 2.2 ohm. That 9 divided by 2.2 ohm gives the 4.09 ampere current as a source current here. 4.09 ampere. So what we need to find out? IN. So once the current is here, the current branch will directly go to 3 ohm and also the 2 ohm. We need to find the branch current of 2 ohm. So as per the current division rule, other resistance divided by the total resistance. Other resistance means 3 ohm. 3 ohm divided by 3 plus 2 into total current. Total current we already find out 4.09. So that's 4.09 into 3 divided by 3 plus 2 will give the Norton current in this branch. So you can find out the Norton current like this. I will repeat once again. The question is current flowing in 10 ohm resistor. This 10 ohm resistor. So in order to find out the Norton's current, you can remove the 10 ohm and place it short. So after shorting, that current is called IN. That is the Norton's current. So in order to find out IN, we need to find out this branch current. What is the current through the 2 ohm? So in order to find that, what is the total current need to be find out? So 9 divided by the effective resistance. Effective resistance means 1 plus 2 and 3 in parallel. 1 ohm is series with 2 ohm and 3 ohm in parallel. So we can have the 9 divided by effective resistance, that is 2.2 ohm here, and 9 divided by 2.2 gives the 4.09 ampere. And we need to find out IN, so that IN is equal to total current into other resistance, 3 ohm divided by 3 plus 2. So it will give the Norton's current IN. Okay, is it clear? And then we need to find out Rn. Is the Rn or Rth what we the same thing? So here it is the removal of 10 ohm resistance here. So after the removal, you can short the voltage source here, and the remaining resistance is 2 ohm, 1 ohm, 3 ohm, like this. You can short this 9 volt, and you can have remove this 10 ohm. You can find out the Rn from here, then 2 ohm in series with 1 ohm, 3 ohm in parallel. Like that, we can find out Rn is equal to 2.75 ohm, and final equivalent circuit can be illustrated as a current source IN. We already find out IN. What it is IN? 2.454 ampere here, 2.454 ampere here, and also Rn is equal to 2.75 ohm here, Rn. So Rn is here, and RL is the load resistance what we removed earlier, 10 ohm. Then you can find out IL, IN, Rn, RL. And also you can find out IL through the current division rule. So it is a principle, it is the steps behind Norton's. So in Thevenin, we actually removed that particular load, and we find out the open circuit voltage. Here in Norton, that remove the resistance and shorted that line and make it as IN. That is the shorted current. So that is used in here actually, IN in parallel with the resistance RN. I think everyone clear about these things, right? Are you able to follow what is Norton? Can we move to the illustration what we can done for MATLAB simulating? Akshay is ready. Can you share the screen now?
Yes, sir.
Yeah.
So
Yeah.
please note down the question. Sir, you are muted, sir. Sir, we couldn't hear you.
Sorry. You can simulate in MATLAB simulating. You can place the 9 volt there, 1 ohm, 2 ohm, 3 ohm as the resistance.
Yes, sir.
Then a shorted current IN you can try with the removal of 10 ohm. Participants, please try from your side and update your screenshot in the chat box as a result. So you can explain. Yeah.
Yes, yes, sir. First of all, design this circuit in the Simulink workspace So I take a 9 volt voltage DC voltage source and then connect it to a 1 ohm resistor, and then the 1 ohm resistor is connected to 2 and 3 ohm resistors. Then in this circuit, 10 ohm resistor is the load resistance. So closing the circuit. Yeah. So our aim is to find the current through this 10 ohm resistor. So using Norton theorem, we can, first of all, I'll duplicate this circuit, and then our first step is to remove the load resistance and then connect the terminals, and then measure the current through this terminal. So I take a current measurement block and then connect the positive terminal to the positive terminal of the ammeter, negative to the ground. And then connect the ammeter to the display. Yeah, first we will find the Norton current. In this case, it is 2.455 amps. And then we have to find the effective resistance in the circuit. So I will duplicate this circuit, then remove the current measurement block, display, and close the circuit. Then I'm short. The voltage source is short, and then now I'm going to calculate the effective resistance, which is 1 plus 2 into 3 divided by 5 ohms, which is 11 by 5 ohms, and then which turns out to be 11 by 5, it is 2.2 ohms. And then next I'm going to create a effective Norton circuit. So we need a volt case DC current source, controlled current source. This one, DC current source. Yeah. This one. Dragging into the workbench, and then for the Norton circuit, the current source should be connected to a parallel resistance, which is the effective resistance of this circuit, the above circuit. So just duplicating it, and this resistance value is 2.2 volt, 2.2 ohms, and then just connected to the resistor. And then in order to produce current using controlled current source, you need to add another constant for constant current source. So constant, just drag and drop it. The current, so the value of this current constant is going to be 2.45 2.455 amperes. Then it is going to be connected. It is connected to the controlled current source, and then the other part is connected to the parallel resistor, and then we need a volt, like we need a load resistance. So the value of the load resistance is 10 ohms. This is 10 ohms. And then I connect this into the circuit parallel to the equivalent Norton resistance. Yeah, disconnected. So I'm going to measure the current through this resistor. So I need a current measurement block. Then to and the current measurement block is connected to the display. So are you guys able to follow?
Participants, please respond. Uh, yeah, please try from your side these things. It's so easy. Just try it. If you have any doubts, please ask. Please unmute and ask. Get a good understanding about that concept. Yeah, Akshay, can you take it on small?
As okay. So to verify this the result, I'm going to connect a current measurement directly into the main circuit. This here, here. Okay. So there is a load resistance here, so disconnected load resistor, load resistor.
Participants, are you able to follow these things in Norton's? Please make a thumbs up for if you are understanding. Please try from your end in MATLAB. Use it for make good understanding about the theorems and about the simulating versions. Once you done this, actually you didn't never forget the theorem understanding. Is that okay from your side? At least participants put a screenshot in chat box if you able to replicate the results. Okay, in Simulink itself, an overview is actually in chat box on asking the overview in Simulink. Simulink actually, it is two last montage. It shows very well the two last montage. Means, Asha, can you show the first figure. Yeah,
This one.
here actually, what we are doing is actually 10 ohm resistor. We need to find out the current flowing in 10 ohm resistor through the Norton's method. So what we do is need to find out the Norton current and Norton resistance. So Norton current means we will remove this 10 ohm and make it as short. So then only it will become IN, the Norton's current. We need to find out Norton's current. Norton's current means IN means the branch current in 2 ohm resistance. So in order to find out that IN, we are theoretically we will go with the effective resistance. This voltage 9 volt divided by the effective resistance will give the total current. The total current is like this. Then total current will split up to 3 ohm branch and 2 ohm branch. We need to find out the 2 ohm branch. So based on the current division rule, we can find out the IN, right? So for the effective resistance RN, so we can remove the 10 ohm based on that 10 ohm terminal, and voltage source should be short circuited. You can have 2 ohm, 3 ohm, 1 ohm in parallel. So at that way, you can find out RN. Akshay, can you take the Simulink?
Yes, sir.
Can you scroll to left once? Yeah,
So
in
this
that
is the
first
main.
thing Akshaya is done is actually that the terminal, uh, how much it's voltage? 9 volt. 9 volt is actually done it, and the three resistance are plotted. Nearly that 10 ohm also there, and after removing that 10 ohm, we will find the Norton current, right? So that is 2.455, I think so. Yeah. So 2.455 is the right, Ashya? Yeah,
Yes,
IN.
yes, sir.
IN is the 2.445 IN.
5, yes,
So
sir.
yeah, that 2.45 IN is specified as here, and effective resistance you can find out like what we find out in RTH in the Thevenin itself. You can find out RN, then RN you can place here, and the current controlled current source you can provide here, and with a value 2.455. Then you can measure the current for the load resistance. 10 ohm can be replaced at the end, what we removed at the earlier. Okay, and you got the current of IL. That is the overall picture for Norton. Any doubts from anyone? Yeah, good Anwar. Yeah, good Jayshankar. Yeah, thank you. Shall we move to superposition? Last topic. Yeah, it just take two more minutes to complete it. After that, we will take superposition.
Hello. Hello.
Any doubts from Jayshankar? Yeah, please.
Sir, sir, there are two types of control current sources. So, sir, what's the difference between
Two types of control.
source? Sir,
Control. Wait. I will check. Yeah, that actually one is freewheeling one actually. Uh, Deshankar, you are which year actually you are now?
sir, I am doing MSc FY.
MSc S5
First year, sir.
first year only. So in actually in power electronics actually there are some freewheeling options also there. So at that time some bypass freewheeling also maybe some circuit is needed at that time. That control current source is applicable. You can have some separate line for that in that symbol. Okay, that is the difference. It's a what now we are using is the normal current control source. Okay, yeah.
Okay, sir.
Yeah, shall we move to superposition? I will share my screen and share. Yeah.
Okay, sir.
So
Yes, sir.
please listen for superposition theorem. In superposition theorem, actually, this is a statement in any linear and bilateral network or circuit having multiple independent sources, the response of an element will be equal to the algebraic sum of the responses of that element by considering one source at a time. That is the superposition theorem stating. That is here actually we are when it is a circuit having two or more sources, whether it is voltage source or current source, more than two independent sources is there. At that time, we are considering one source and other source become open or shorted. Current source become open and the water source becomes shorted. Other source becomes shorted or open. One source considering at a time. And then we analyze and for one particular some terminal value is specified or a particular resistance value is specified for that particular question. We need to find out that particular current or voltage at that time. Okay, and considering one source at a time. If we having in the network two or three sources, considering one four source at a time, we can have two or three cases and addition, and we can have a summation of that current or voltage at the end. That is a superposition theorem. We will look into a problem and we can have more understanding on that. See here, one problem is here. I took from a by just learning app. Some circuit is provided here. Here it is 20 volt, 5 ohm, 10 ohm, 10 ohm, 20 ohm, and 4 ampere. How many sources are there here? Two sources are there. Only one 20 volt source and a 4 ampere current source. So one source we act on at a time. So here we are considering 20 volt for the first consideration. 20 volt for the first consideration means the participants please respond. 20 volt for the first consideration means we are 4 ampere. This one is we are going to open, right? 4 ampere we are going to open. So if we are open this thing, the branch is irrelevant, right? 20 volt will be there, 5 ohm will be there, 10 ohm will be there, 10 ohm will be there, 20 ohm will be there. The question is find the current flowing through the 20 ohm using superposition theorem. So we need to find out the current through the 20 ohm when 4 ampere is open, 20 volt only considered. This is a circuit for that. We open this terminal and 20 ohm is there. We need to find out the current through the 20 ohm. We can use the mesh analysis or a node analysis or a current division. You can have the current passing through the 20 ohm. Here in this presentation slide, it is putting us for nodal analysis. So it's V1 minus 20 divided by 5 from this node, V1 by 10 and V1 by 30. V1 by 10 plus 20, that is V1 by 30 equal to 0. So you can easily find out the node voltage here and the branch current as V1 by 30. So you will get the branch current for 20 ohm is 0.4 ampere. That's one current you got easily. That is 0.4 ampere. So what is the second step? That is, it is first step. Second step, 4 ampere only we should consider. 20 volt should be shorted. So 4 ampere only should consider means this 4 ampere only should consider 20 volt, that branch should be shorted. So 4 ampere is considering from here. We need to consider the what is the current for 20 ohm here. See 20 ohm here. So when the current flowing through here 4 ampere from here, you can have um, uh, we can have a two node voltages, or otherwise we can have like this 5 and 10 are in parallel. So 40 by 3 you can take it 40 by 3 ohm, because we need only 20 ohm current. 20 ohm current we only needed, so we can have it in parallel like this 5 and 10. So 40 by 3 ohm in this pattern, so that the circuit can be reduced to 40 by 3 ohm here, and 10 and 20 we can have it in 20 ohm here. Okay, 5 and 5 into 10 plus 5 plus 10 is the parallel here. 10 ohm in series, 10 in series with 5 ohm in 10 ohm in parallel. So we'll get 40 by 3, then 40 by 3 ohm here, 20 ohm here. Then 4 ampere is here, so you can have easily a current division for 20 ohm resistance. So you can have the current as 1.6 ampere passing through the 20 ohm. So we already find out one current 0.4 ampere, and for the 20 volt consideration, then 4 ampere consideration, we have current as 1.6 ampere. That 1.6 and 0.4 can be added, and we get the 2 ampere like this. So 1.6 and 0.4 can be added to get the 2 ampere current. So 2 ampere is the current flowing through the resistor 20 ohm. So we can find out by superposition like this. So here the consideration is, I am repeating once again, 20 volt one source at a time. That is first case 20 volt at a time. Then you can have 4 ampere should be open. Then you can easily find out current through the 20 ohm. You can use node analysis or mesh analysis or current division. You can find out 20 ohm, 20 ohm current. And also second case 4 ampere will be there. 20 volt should be shorted. So at that time, what is the current through the 20 ohm you can find out. That's second step. So you will get I dash and I double dash, or I1 or I2. Then you can find out the final current I dash plus I double dash, or I1 plus I2. You can find out 2 ampere. That is the principle behind superposition. So can you take it from this side? Akshaya,
Yes, sir.
can you take it down? Yeah.
Sir, MATLAB script.
Yeah. We can verify through a MATLAB script and also a Simulink version from Deep and Akshaya. Yeah, please. Akshaya.
Yeah. I hope you can see my screen. Okay, so let's start with the question. So we have a simple circuit given over here. We need to find the current I flowing through the central branch, wherein in the given circuit, we have that there's 5 volt source over here and a 10 volt source over here, a 20 ohm resistor, a 10 ohm resistor, and a 10 ohm resistor. So we are supposed to verify superposition theorem in this circuit. So can everyone write down the question? So everyone understood what we're basically supposed to do in superposition theorem, right? We remove one of the 2 volt sources and consider only a singular volt source, find the current across the whole circuit, and consider the second volt source, find the current across the whole circuit, and add those two. So in this case, we would take only the V1 source over here. There will be an R1, R2, and R3. So when the current flows through these arms, we get some values. So to calculate those current, we have these formulas over here, which is this is basically the current divider rule. So when calculating this, we have the net resistance at the bottom over here, and this is the net current. So but this I1 is nothing but the net current flowing through this arm right here. So when we calculate that, okay, so here mainly we have this long expression R1, R2 plus R2, R3 plus R1, R3. We'll assume that as X. So when we assume that as X, we'll have V1 into R2 plus R3 by X. Here we're using to find the R2, this branch current. Okay, 1 second, I have a mistake over here. It is in this direction, yeah. So when this I2 current that flows in this branch, we use the current divider rule and we arrive at this equation. And similarly, to find this current, we basically subtract I1 minus I2. So the leftover current will go in I3, which is nothing but I dash that we have assumed over here. So while subtracting, we can take this I1 common as there's I1 un and I2 and I1 over here. This I1. So it is nothing but 1 minus R3 by R2 plus R3. When we solve this, R2 plus R3 is cancelled, and we'll have nothing but V1 R2 by X over here. Similarly, while considering the second volt source, we would have a similar outcome. So over here, the only differences over here we'll get is I double dash is V2 R1 by X. Because when considering the opposite direction, we will not have R1, but instead we will have R2. So that is why we'll have R1 in this equation, the opposite arm, and R2 in this equation, the opposite arm. So do you get the point? We are using current division rules to get the branch current, the central branch current. Any doubts on how I got these two equations, this I double dash and I dash? Okay, so now when implying the superposition, we know that the net current through the branch I is the sum of the two currents using the two voltage sources. So there is nothing but I is equal to I dash plus I double dash. When we do that, we get that V1 plus V1 R2 by X plus V2 R1 by X. So basically, to find the net current through that arm using superposition, we are going to use the small equation right here. So rather than using these big equations, we ended up with a small equation. So now to implement this in MATLAB, we have 1 second. Yeah, so in superposition, let's run it. So first we have some voltage source. What was the voltage source? The first voltage source is 5 volt. Second voltage source is 10 volts. The internal resistance for V1, which is basically this R1, which is 20 ohms. Similarly, R2 is 10 ohms and R3 is also 10 ohms. So here again, like how I assumed X in the equation over here, this X, I have assumed an X also in the code, which is R1, R2 plus R1, R3 plus R2, R3. And that I have assigned that to I1, I2, and I is essentially the sum of those two. And in the last, I've just printed all the three. So f print f, the current I1, which is the voltage by voltage source one, which is I1, which is nothing but V1 into R2 by X. And current I double dash, which is by voltage source 2, is I2, which is nothing but V2 R1 by X. And lastly, by using superposition, it is nothing but the sum of the two. So in the end, we get the answer. So I dash is going to be 0.1 ampere, I double dash is 0.4 ampere, and the sum of the two, I is 0.5 ampere. Any doubts? Like, everyone understood what I explained so far? You could try with
Participants,
the
please ask your doubts. Superposition is quite easier one. So you need to find out the two currents from two cases or two voltages from two cases, whatever. This question is actually demanding two currents. That's why. So the current you can you can find out the estimate the current by partly by considering one of the sources and add up at the end. That is the steps behind the superposition theorem. So try it from your side and get us the result through chat box.
So if everyone understood, can I get a thumbs up?
Participants have a doubt, so anything?
So in case no one has doubt, I guess we could move on to Simulink. Okay, then.
Yeah, wait for 2 minutes, Deep. Akshay, wait for 2 minutes. Participants makes correct from your side.
Okay, sir.
Devish, just share the screen.
Yeah.
Participant, just try from your side the codings and all. What Deep conveyed about the branch currents and the codings, how it can be estimated, and how the resultant current can be formulated. If you have any doubts, please ask. I know you were all after lunch, maybe sleepy, so please make some effort from your side, from the laptop. Just try in your MATLAB. Okay, Deep, you can start.
Here's the question. Please note it down. So we have to find the I current passing through this terminal AB through the resistance R3, which is 3 ohms, And then there are two voltage source connected. So first of all, first we try to make a circuit using Simulink. So R1, then R2, then R3. So then R1 is 1 ohms, then R2 is 2 ohms, and then R3 is 3 ohms. Then there are two voltage source. So it is 10 volt, then this one is 20 volt. Then connect the terminals. And then our aim is to find out the current through this resistor. So using superposition theorem, I'll create a duplicate circuit, and then this two duplicate circuits created. Okay. Now I will short 1 volt voltage source, and then find out the current through this terminal AB using a current measurement block. And connect it to a display. And then I will get the current through this terminal using this circuit when the V1 is active. And for the second circuit, let me short circuit the V1, and then let V2 contribute the voltage to the circuit. And then I'm connecting, I'll duplicate this thing. That will be easy. Short circuiting V1, and then placing a V2 here. Yeah. So can you guys follow up? Please respond using thumbs up.
Please try to
Yeah.
make it from your side, your MATLAB.
Got to give for the then just run it. Okay. Now I found out the two currents, and the sum of these two currents would be passing in this terminal AB. To verify this, I'm going to connect a current measurement in this terminal, the main circuit. So, put it into a display. Yeah. So, run. I get 3.636, which is probably the sum of 1.818 plus 0.90, 0.9091. Okay, it's different. Okay, I guess I didn't give the correct. Yeah, it's 20 volt. Yeah, then it should be correct. Yeah. Now 1.818 plus 1.818. So the sum of two currents is equal to the current passing through the circuit. So hence the superposition theorem is proved. Any doubts? Please ask.
Audience, please do it from your side. Is there any doubts from your side regarding network theorems and any of the portions from the Thevenin, Norton, superposition, anything? Okay. Is there any questions, queries from your side regarding simulating and scripting? Then we can, I think, wind up the session. we are expecting an open feedback from everyone. And if possible, everyone turn on your video. And if you share some open feedback, also fine. And also on chat box, I shared one feedback form. Please fill it. And attendance form for session 4 also distributed. And after checking for session attendance, we will consult. We will Malavika will share the eligible certificate holders list. Once you can confirm the name and institution once we can go for the certificate for participation for this workshop. And we will make it ensure that more than 3 sessions, at least 3 sessions, you need to attend that to get the certificates. Okay, that's a condition for the to hold the certificate. So if you have any open feedback also, you can write it. In the last comment we put it as there's a paragraph wise. You can give suggestions if you want more any this kind of workshops in any other topic. This is only a smaller topics we covered about the network theorems only or circuit theories only. Circuit theories also need to be addressed in so much response curves is there. Differential equations otherwise we can expand. So much theories can be expand, and AC fundamentals are there, so that also can be expand. That we can, if you give a genuine feedback, we will come up with another series for the MATLAB workshop soon itself. So we need an open feedback from everyone. If you anyone have um, need to comment about the feedbacks and all, you can, and we are expecting an open feedback. You can unmute and tell us. 1 or 2, 3 we are expecting. Yeah. It's a small attempt from my me and my students and our Malavika itself. So if you have some corrections is there, we can correct it and get it back to another good session for coming in the coming season itself. So that's why we are expecting your genuine feedback. If anyone unmute and tell your feedback, it will be good for a good wind up, an open feedback session. So and if you can open your video also, it is fine. We can look up everyone. So we are expecting that too. Yeah, Amit, not Amit. Yeah, Deep, Akshaya, Malavika, can you open your video? And participants, you can also open your video and share your feedbacks if genuine cases are there. We are expecting that too. We are also humbled to receive your feedbacks. So we also know that it's a holiday for you, and you are taking so much time to learn for that. So that will be acceptable for off days for us new learnings and all. So yeah, can you anyone comment about the please Jay Shankar? You can those most of the active participants. I think Mirza is not available for session 4. I think so. Yeah. So many active participants are there. We are expecting a lot of more for Amrita School of AI. We are conducting again few workshops. So I think food. Okay, fine. Okay, fine. So Anmol, anyone have the open feedback? It will be good. I think so. Yeah.
So the workshop was very well done, sir. It was executed on point, sir. Just that if we had more time, more topics could have been covered, and it could have been, a little bit more better, I feel. As of now, this is very good. We have learned a lot, and then we're also able to learn more about like the applications of MATLAB and how it is useful for. As I'm a electrical engineering a triple student, I learned how it is very much useful for me in my day-to-day life as it progresses, as my semesters go. That's also thank you.
Actually, I thought like that in other colleges and all, even electrical engineering students also we are studying the circuit theory and basic network theory, network theorems and all, but we are not utilizing the simulation platform quite not well, even in the lab itself. So I think it will be a good opportunity to outreach our students to have some more kind of exposure in simulation platform. That's why we designed this course syllabus. But we are not that we know that we are not completing the course syllabus itself. So I think we will complete by the next season. If you are interested and open feedback will be there, we should definitely go for the next season with the good bang of yeah, with the students itself, student support itself, where we can have the next season for the additional topics. Yeah. Yeah, Mubulama, yeah, please, sir. If you have some comments, you can. We are so humble to receive. Chubaka, yeah. Yeah, you are muted. You are muted. Yeah. Can you unmute? Speak. You are muted now. Yeah. Okay, fine.
I don't have everything to say, but I'm so happy to participate in this worksheet, and I wish I will be present in another. Thank you very much for to, your time to teach us. I'm so very happy.
Sure, sure.
That,
Thank you, Chubaka. Thank you. Thank you. So, anyone from Itikamin? Uh, you are, I think, you are a regular participant for Amarda School of AI workshops. So, from your side, anything is there? I mean, and my students, there are so many students of mine itself. So, any students can also give an open feedback. Yeah, Deep, you can share the share to our WhatsApp group. You are in WhatsApp group, right? I shared that whatever I present. These are all
Yes, sir.
these are all available in the. I already say that then not only in MATLAB Central and also in MIT Courseware. There are so many materials are there. You can refer it. Whatever I prepared for the presentation slide, I shared in the WhatsApp group, and Deep also will share their MATLAB codes and all. That may be useful for you. Uh, Try it out, not copy everything, but try it down and make your own logic to code something. Always better to refine your codes, and in your user perspective, it will be become more and more better way. Everything good, I think so. Try to fill the feedback as much as soon as possible. Uh, Thank you all. Thank you on behalf of Amrita School of AI. Amrita, Malavika, you want to communicate something? Malavika is also one of the coordinator for this workshop. Uh, okay, fine. Uh, Fine. Okay. Thank you on behalf of Amrita School of AI. I want to thank every participants, my students, my co-speakers. So everyone, I want to thank completely for the attendance, and we will come back with another good programs in soon itself. Yeah. Thank you. Thanks a lot.